A pleasure to introduce our final panel moderator. Dr. Chester Kennedy is the CEO at Bridge, an advanced manufacturing research fabrication facility working to bridge the innovation development gap for the smart sensors that will support the Internet of Things. Prior to Bridge, Dr. Kennedy spent 35 years in the aerospace and commercial electronics industries and now draws on that experience to focus on R&D and microelectronics fabrication infrastructure, which are key to facilitating partnerships that will move industry into a new era driven by smart sensors innovation. Chet, let me give you the floor if I can, and you can introduce your panel as well as your panelists.
All right. Thank you very much, Tom, and thank you to all of you that have hung in here. You know, I'm sure that if you exclude me from it, that we have saved the best for the last, so that you folks that endured here would get a real some real value out of hanging in here with us. And so as Tom shared with you a little bit, some of you have asked throughout the day, what is Bridge? And Bridge is really an economic transformation project that we're doing down in Osceola County that's centered around bringing some advanced technology, specifically a microelectronics fabrication facility to the region, in anticipation that having that capability here will attract other industry to come and be partners with us. And one of those partnerships, we're really proud to be partnered with Siemens in evolving something called a digital twin for semiconductors, if you can imagine that, right? So with Fram and his team working with our folks, we're trying to finish the definition of what that exactly is when you start talking about building a digital twin down at the level of where atoms interact one-on-one with each other. That's a little bit of an interesting challenge that, much like the overall concept of digital twins was ahead of its time for a while until technology kind of caught up. We're probably pioneering something that may be a little bit ahead of its time, but we're confident that with a partner like Siemens, we'll evolve that together, and it'll be a great tool that will help us as we create new devices to be able to do so more efficiently, and also be a great educational tool to allow students some new ways to design integrated circuits before they actually walk in to a silicon foundry to start thinking about producing them. So with that piece of background, I can't seem to escape this thing called digital twins. I spent the last decade plus a little bit of my Lockheed Martin career working in the modeling and simulation industry, and there we were either trying to use something very similar to a digital twin to predict the reliability of a weapon system and to be able to develop a logistics supply chain that would make sure that the maintainer didn't even have to actually order parts, that based on understanding of what was coming out of the digital models, that if they were operating at a certain tempo in a certain environment, that these parts would be needed, and so that they would automatically get ordered and they would just show up, and when the maintainers needed them, they'd be there. Or we were trying to create digital twins of the weapon system so that the airplanes that we had pilots actually flying, that the digital model of those airplanes actually performed the same way that the physical airplane would. So that if somebody's coming in and they're facing a 30-knot crosswind on landing, that they would know what that felt like, and that the digital model in the simulation would behave the same way that the real airplane would, so that the operator and pilot would know what that was like from having experienced it in the simulator and not have to wait till the first time they got out on a really bad day to see what that experience was like. So I can't seem to get away from this concept, so it's time to embrace it. And, you know, the first person that we're going to introduce here on the panel, Dr. Michael Greaves, he's the executive director and a research professor at Florida Institute of Technology, Center for Advanced Manufacturing and Innovative Design. But a lot of people that I know refer to him as really the father of the digital twin. Whether he actually coined the word or not, you can ask him that, and maybe in some questions, or maybe he'll share a little bit of that with you. But in terms of the concept and his introduction of that concept in 2002 and the books that he has written around product lifecycle management and Virtually Perfect, they really introduced that thought pattern, the concept of being able to create a digital model that really replicated what was happening in the physical world. And so he's been a great thought leader in that. He's also an entrepreneur that has launched and taken public a very well-known national systems company. So you can quiz him a little bit about that if you want to hear more about that. He's got a lot of stories. I even learned one last night at dinner with him that I didn't know, and it was about his involvement in the golf industry and some simulators in that space that many of you have probably experienced if you've been to one of the high-tech golfing simulator installations around the country. So, Michael, without further ado, I'm going to turn it over to you. Thank you. Thank you very much.
So good afternoon, everyone. I'm going to show you sort of a quick, brief clip of a preview of what I'm going to talk about this afternoon in terms of sort of three topics: the digital twin, manufacturing, and Industry 4.0. So if I can get you to... So that's my Center for Advanced Manufacturing Innovative Design in beautiful Palm Bay, Florida. I'm going to give you a preview. So this was the original digital twin. And you can see it goes back to 2002, and it didn't even have a name. Okay, so at that point in time, it was just called the conceptual ideal of the digital twin. This is currently, and it was developed at NASA. And so, rather than having to ask me the question, I'll basically give it to you. Is I didn't name it. It was named by John Vickers of NASA, who didn't like my information mirroring model and said that's a stupid name, and I'm going to call it digital twin. So. Thank God for John, because I probably wouldn't catch on. Here's the digital twin of the future. Is we're basically going to look at how we're evolving the digital twin. And so I'm going to sort of give you sort of my perspective of what the digital twin is, and because you've been hearing about it all day, and so what really it is. And so it's really sort of three pieces, okay? It is the physical product that we've always had. We now, because of the technology and the ability, and especially being able to do three-dimensional versions of it, we can strip the information off of the product and create a virtual version of it, okay? We then connect those two areas with data coming off the physical product and information flowing into the real world, okay? And some people, in fact, from my perspective, that would be what we would call the digital thread, this connection between the physical product and the virtual product. I particularly don't like the term digital thread because I've hung on by a thread too often in my career. So it has bad connotations for me, but I think we're kind of stuck with that terminology. But the issue of it is that we have these sort of three constructs: the product we've always had, the virtual version of it, the digital twin version of it, and then the data coming from collecting it off of the product from sensors and things like that, and then feeding information that we can use. And so the premise there is that we have these sort of three things that we operate on. So why do we really care? Okay, so I heard a lot about data. I don't care about data. Okay, data is merely symbols that we basically collect. Until I can turn them into information, data doesn't mean anything to me. And so what the version of the digital twin is basically the use of information. And so why do we care about that? Well, we care about that because everything that I sort of do is grounded on this basic premise, is that for any task that we perform, we can divide it up into two major categories, okay? And I think you heard from the previous speaker talking about power, and I want to use the minimum amount of resources. So if I take any kind of task, it doesn't matter whether it's a manufacturing task, whether it is a service task or whatever, I can divide it into two areas. One is the least amount of resources that I can consume in order to be able to perform that task, okay? It's called lean manufacturing in the manufacturing area, but the intent is if I was omniscient and omnipotent, and if you ask my wife, she'll tell you I'm not, that I would only use that minimum amount of resources to do that. Everything else is wasted, okay? And so the intent is, if we're in a resource-efficient universe, which we are, we want to minimize that use. And so the idea is that I can trade information off, not for the resources I need to do that task, but for the wasted resources. And so the whole focus of this is can I basically use information to trade off wasted resources to complete my task? That's why the digital twin is really important in terms of being able to have that information to trade off not the resources I need to do the task, but the wasted resources. And that's why the computer industry works and why we've done such a good job in terms of being able to use information to not waste resources. The example I always use, I could talk about nuclear reactors or aircraft carriers or things like that, but the one I always use is a bike at Christmas, okay? When I did a bike at Christmas for the kids, it's basically 8 hours and I had parts left over. The guy at the bike shop did it in 10 minutes and it was perfect, okay? He traded information off for the physical resources to do that, okay? But you have to remember, information is not free. The whole idea where this works is the cost of information less than the cost of wasting resources? And if the answer to that is yes, you ought to basically go do that, okay? And luckily, that pretty much is how we look at it. I might want to mention, so we just heard digital twin kind of used as this overall thing. There's 3 versions of digital twin. There's a digital twin prototype, which is the information about the product you're going to make. And so the reality of it is the digital twin exists before the physical one, right? I mean, nobody walks into a factory, pounds some metal, and says, I hope an airplane comes out of this, okay? So the digital twin exists before, and that's the information that I'm going to need in order to be able to make a physical thing. You have the digital twin instance. So once I start making things, I want to create a digital twin version of it. And in fact, it doesn't, the oldest twin always gets sort of the most attention. There is a thing called a physical twin, which is the actual product itself. And this is where Dr. Kennedy's stuff comes into play, is being able to sensor this stuff so I can get data and get information and create information about it to basically be able to do those kind of capabilities. And so you have a digital twin instance, which basically is every single thing you make, you want to have a version of it that you can track through its life. Now, I drive everything from use cases, so for airplanes or aircraft carriers or nuclear reactors or things like that, I want a digital twin. For paper clips, not so much, okay? And so it really is involved, what's the use case that I can use this for, but I want to create a digital twin instance for complex products that I basically create. The third type of digital twin is what I call the digital twin aggregate. And this is a really interesting one. What makes everything kind of work is that if I take all my digital twin instances and I take all the data and turn it into information about how this thing's performed, I can do such things as prognostication. Predict failures by looking at correlations between when this happened and this happened, I had a failure. So I can get out in front of it and basically be able to replace things before they actually break. My contention, by the way, is as we move forward and where the modeling simulation piece comes here, is I think all products that are complex will have what I call front-running simulations, which is we will run simulations not in isolation, but every product will take the data it has at time 0 and predict forward. So in factories and things like that, I basically want to see what's going to happen 5 minutes, 30 minutes, a day, a week ahead of time, and I will continue to run that from time 0 things. So those are the 3 types of digital twins that we have: digital twin prototype, digital twin instance, and digital twin aggregation. So the other sort of thing is now we move into manufacturing. I know we're in the biggest service area, in maybe in the world, but we need to manufacture in this country. I mean, there are a number of reasons why that is. The most important is probably national security. But the other important thing is that companies that don't manufacture basically don't thrive. And so we have a problem in this particular area. And so the problem is that in 2015, in the high-end products, computers and electronics, industrial products, communications, things like that, we ran an $800 billion deficit in terms of those kind of products. We ran a $100 billion deficit in terms of advanced products. We can't afford to do that. We've basically got to do a better job in manufacturing. And so there's all kinds of other incidents in terms of won't be made up by services, even though people think that's the case. Services aren't growing fast enough. In the same period of time, we only have about a $200 billion surplus. So we've got to basically be able to manufacture. So that moves us into this Industry 4.0. And so what is Industry 4.0? Very simply, we're supposedly in the fourth stage of industrial evolution. First was mechanization. Second was electrification and mass production. Third was putting computers on the factory floor. The fourth is this IoT, Internet of Things, this smart machines, okay? For those of you that are interested, if you're talking about manufacturing, it's not IoT, it's IIoT, so Industrial Internet of Things. And this is the idea of having smart machines out there. So it's not only called Industry 4.0, it's called smart manufacturing, which I have a problem with because it sounds like we've been doing dumb manufacturing up till now. I think it's sort of a little bit presumptuous. But smart manufacturing is this idea of having machines all connected together that basically can adjust it. To add a little bit of confusion to it, Germany has a thing called Industry 4.0, but it's INDUSTRIE 4.0, which is actually a program that Germany has in order to do advanced manufacturing. But it's not only smart machines, it's basically horizontal integration across the supply chain, vertical integration across the supply chain, horizontal integration longitudinally, so engineering is involved throughout the whole entire product. It has to do with regulation, things like that. So there's still a lot of confusion around this whole, industry, IoT, Industry 4.0 sort of thing. So hopefully we can clarify a little bit of that. But it is about, smart machines connecting together to be able to produce products better and across the supply, the whole supply network. Tying it back to the digital twin is my contention is that you have to have a digital twin if you're going to start putting intelligence into machines. And why? If you let machines start to talk to each other and make decisions about how they're going to react, my contention is that the opportunities for catastrophic failures are probably pretty high. And so you need a digital twin to basically let us control these sorts of things. So anybody that keeps talking to me about we're going to put AI on the factory floor and have these machines make decisions about doing things and adjusting for things, plus the fact that my biggest concern about this is cyber physical security, my contention here is that you better have a digital twin that sits on top of these smart machines, factories, and Industry 4.0 in order to be able to stand a chance of making sure that you can stay in control of the situation. Now, I'm not worried about Skynet, okay? But, I do believe in Mr. Moore, in the fact that if something can go wrong, it will. And so this ability of having these sorts of things with unexpected consequences, I think is fairly high. So the kind of issues that we're going to have to wrestle down, and you've heard some of them today, and the AI stuff is interesting. I think that there's a counterpoint to the fact that our kids won't drive, do music or whatever. My contention is that we can simulate everything other than human endeavors, and so I think that physically we can do that. In fact, I have sort of an idea of testing for virtuality that says, that we basically have the ability to simulate all the physical stuff, but we will never simulate human minds, okay? So I'm not too concerned about it. The driving thing might be true. In fact, I remember telling my granddaughter, she was taking driver's training, that my grandmother didn't drive at the beginning of her life, and she wasn't going to drive at the end of her life. And she said, "Why did I take driver's training?" And I said, "Well, honey, you've got a few years to worry about that." But I think that the cyber physical security aspect of this and the threat, how many of you heard of ransomware? Yeah, so it's one thing for your computer system to basically be hijacked and ransomed. Think about doing it to a factory, saying, I have basically taken all your smart machines, and in an hour they're going to go into chaos if you don't if you don't send me $1 million in Bitcoins in the next hour. So I think that we have some huge opportunities, but we also have some huge challenges that are going to go. So in summary, digital twin is an interesting thing. It's driven by use cases, so there's not one digital twin no matter what. We need to do physical manufacturing in this country, okay? And we're not going to basically work harder or longer, but we're going to have to work smarter. And I think this Industry 4.0 and the ability of basically applying the digital twin to manufacturing so that we can basically predict factory performance. And again, my focus is the minimum amount of resources in order to produce things. So mass customization, our ability to do innovation in the manufacturing area has been lacking. We've been innovative in the social media stuff, which I will also argue maybe not be a great thing. But we basically need to do more innovation in the manufacturing area, even in areas like Florida. If we go to the Space Coast, the activities of SpaceX and Blue Origin and Northrop Grumman, that's manufacturing that we really need to have to balance out our service economy. So with that, thank you very much. I'll turn it over.
All right. Thank you, Michael. So get your Twitter accounts active and get your questions in. This is your chance to ask really some of the pioneers in the field some really hard questions, and I hope you don't let me down and don't leave me to ask all the questions here. But in helping us wrap up here, we're fortunate to have with us Steve Dertine. And Steve is the Managing Director of the Office of the Chief Technology Officer for PTC. And Steve is responsible for driving the technical strategy of PTC and helping to be an evangelist for that out in the industry with their partners and their customers. And really, Steve, I think from what I gathered from our conversation here this morning, you're really focused at helping companies unlock the value that's being created at the convergence of the physical and digital worlds. And maybe you can tell the audience a little bit about that, and it's over to you.
Thank you. All right, so the hardest part about being the cleanup batter in an event like this is to show you something that you didn't see before. So we'll see how this works. I'm gonna have to apologize to Scott. The only thing I don't have is quantum, but I'll show you ANSYS, MathWorks, a low-code environment, augmented reality, washing machines. I will show you washing machines. I promise you that. Electrification, additive. We'll go on and on, but. PTC, like Siemens, like Dassault, like MathWorks, who's actually PTC's neighbor in the Boston area, we're all global software companies helping on the convergence of data and simulation in the context of product development. PTC being one of the largest software companies in the Boston area, we're really driving on both the IoT and the augmented reality space, or AR and VR, as well as digital twin definition. So this is the history or the backbone of PTC has been really in what customers do with CAD and PLM solutions and designing. You don't wake up in the morning and even get out of your house without encountering a product that was designed, developed, basically created, manufactured, operated, and serviced by one of our customers. So if you, some of you will actually see your logos on this chart, but essentially anywhere where there's a physical product being made, the products all range and vary, from mowing and kitchen faucets and bathrooms and so forth, all the way up to some of the largest, most complex products being built by the likes of John Deere and Caterpillar. The complexity that they manage is pretty remarkable. I was just at one of these customers last week, and they did a mathematical assessment on their product, and they said, their product has more variation than there are grains of sand on Earth.
Oh.
Gets better than that. And more variation than there are stars in the universe. So I had to figure out how to top that. And it's all about perspective, but not quite as many molecules as there are in a drop of water. It's all about scale, right? But huge variation. The idea of a product of one. Some of their factories will produce 50,000 tractors a month, And out of that, they might only produce less than 2 that are of the same configuration. And if they did produce 2 of the same, it's likely because the city of Orlando replaced 2 tractors that month and they put them on the same order. John Deere is our first customer, so this is loosely modeled after them. And if you look at the evolution of product development, long ago, in my grandfather's lifetime and in my father's lifetime, we often just talked about a tractor as a very mechanical-oriented product. As we added software to it, they became a lot more intelligent, and certainly drove having software developers inside of these organizations. And then when they became connected, we're now seeing new value streams being created where they're operating and managing service different. You might experiencing that when you go up to an ATM, and the ATM says, we apologize for the inconvenience. You know, this ATM is currently being serviced, yet nobody is around. And it's partly because there's technology now inside of a lot of this to allow them to service it. But as that spans over, a lot of them, we talk about smart cities. I'll talk about smart farming in this case. How do they work in a complex system of systems? And then all the way up into high-performance farm management systems and so forth. And this is really kind of the continuation in their business model. There are a lot of other business models that are fairly similar to this, but the complexity is obviously compounding as it goes up. Symbology is a little bit interesting when you look at logos and things like that, but we really are a company that is on the convergence of where physical and digital is by being one of the leaders in IoT technology that our customers are putting into those products, as well as incorporating it into the early design side of what goes on in there. So a little play on symbology here, this notion of a yin and a yang, 2 opposing forces that work in concert with each other. So if we said, look, we have a digital design, and like Michael said, you don't really just create a robot. You don't walk into a factory and create one. You can definitely buy one on Amazon. You can get it from a variety of different places. But there's somebody put a lot of effort into doing that design. You can definitely put that into motion into a physical product, Industry 4.0 technology. But I'll talk about additive or 3D printing as one of the disruptive forces in manufacturing. So there are now companies like Lockheed Martin and others that are looking at fundamentally rethinking how they actually manufacture components and assemblies and products that might even categorically remove the need for factories. So in some cases where they're doing part consolidation designs on products that take what traditionally would require 300 components, consolidate that down into a single part that they can print in metal or plastic. And as a virtue of doing that, they no longer need everything that it took in the supply chain for those 300 parts. They don't need that factory anymore. They might not even need some of those suppliers anymore. And therefore, there is a real rush to occurring now, even though additive or 3D printing has been around for 20 years, to fundamentally rethink what that does in the industry. We'll talk about that. IoT is a way of taking that physical product back. It turns out not everything can be created greenfield with IoT in it. In fact, a good majority of our business comes from a brownfield, so it was something that likely was created. The question came up earlier, how do I get simulation data into an environment that for which I didn't create it? And there are techniques and technologies that are out there to kind of help customers leverage that data, but we connect a lot of assets that the factories themselves did not do any definition of. A lot of assets that customers themselves have had in the field for 10, 20 years and driving IoT strategy with that. And as a new product, a new generation of capabilities come out where their business model is dictating, we help them on that as well. And we're one of the few companies that actually figured out how to connect it back to augmented reality. So we're also one of the leaders in terms of augmented reality technology, and I'll show you a brief glimmer at that, even though that's not the context here. Take products and just substitute factories, or for people that run oil and gas and smart cities like municipal water supplies and so forth, operational settings, if you will, places where there's highly repetitious work, lots of assets. We would say where dirt and grease get under your fingernails a little bit, and there's a lot of capital equipment in there. That's also an equal opportunity case for applying this technology. Portfolio-wise, just like others, we have a myriad of tools on the design side. You saw a number of those from Siemens earlier today. We have pretty much all the similar technologies there. We do partner with ANSYS. We do have customers that work with MathWorks, and I'll show you some examples of that as well. and really recognized by industry as the leader in almost every measure on the IoT side. So it's interesting when we look at these charts, but our neighbors at Amazon and Microsoft are definitely in here as well, and we work with our customers and those technologies to kind of bring that together to solve the greater challenges that they have in what they're doing with industrial IoT, and ultimately driving business value for their organizations. So if we think of the different, I'm just going to focus on factory of the future a little bit, digital factory, Industry 4.0, a lot of people call it that, but there really are three attributes here that organizations are looking at. You could actually equate this, there are three technology waves. The IoT technology wave is here and has landed for a couple of years now. It's maturing, and there's obviously a lot of fantastic technology coming. We do that with a technology we call ThingWorx, and I'll show you some examples of that here in a minute. But there's a big human component as well. We talk about factories and ailing workforce is one. So a lot of the senior experience that's out there, whether it's in service organizations or inside operations, are out there, and how we use augmented reality technology to both train the new workforce that's coming in, as well as to provide advisorship. So some of these products have so much variability to it that the moment that you come up to it might be the first time that you've ever seen it. And so how do you actually deliver a service organization with the skill sets that it takes for that type of complexity? I'll give you one really brief example, but I could spend a whole day on just what we're doing in augmented reality. And lastly, like I mentioned on additive manufacturing, this is one of the disruptive trends. You might not need the very factory that you were looking at applying IoT technology for. You will still need a factory. It will just look very different in terms of the equipment, the processes, and the technology that are in there, and how that all comes together. Our definition of digital twin is not that much different than what you heard earlier today, even from Michael's definition. So it's really exists of a definition of a digital of a product or a machine. So if you're talking about a factory, we generally are talking about machines, talking about products. A process, so if you're in oil and gas, or if you're in a city, generally we're talking about cities and infrastructure as processes, or systems, so large complex chain of systems working together. And it's physical experience. Equate physical experience here to IoT data, since most physical devices don't really have emotions to share with us, they just share their data. But without that data and without the connection between the two, all you really have is a digital definition. It's maybe based or grounded in some facts, like the simulations that we do are based on the best knowledge that we have. But if we actually apply real data from the real environment into those simulations, we can enrich them, make them smarter, and help drive innovation. There's a little bit of an evolution in terms of how customers are advancing through this as well. So foundational understanding, we see digital twins. I can actually, for a lot of customers, if they say, what does my digital twin look like? And we would say, well, it doesn't have to be perfect. A lot of the definitions that they read really exude this need of having all the perfection, a lot of the simulation, a really rich data set, and quite frankly, in many cases, it's just showing them what they actually have today. They may not like it once you show it to them, but that foundational understanding, getting connectivity and putting data in place helps them drive a little bit of operational improvement. As they start to figure out how to put those into how human-machine interfaces work and dashboards and so forth, they now have a fundamental working knowledge. The greater majority of the manufacturing world likely knows this. Six Sigma, all the Deming work in factories and so forth has kind of gotten us to this state so far. But now the advancements are coming where edge computing, edge analytics, the use of augmented reality, down on the bottom on the digital side, more and more third-party, in particular cloud-based applications. You should kind of equate it to that, kind of coming into the space. And IoT simulations, so driving more simulations into that process is really the next advancement. And if you have not seen an additive manufacturing process, like a metal process, this is maybe one of the pinnacle things that's coming that really requires all of the simulation and all of the engineering, all of the technique, because for the very first time on that machine, we're literally trying to recreate what Mother Nature does through cellular division. And there's a lot of interesting things that go on inside the engineering process for that we just are just getting started at. Blockchain and artificial intelligence certainly be applied up here. AI, I would think of also in terms of how we're actually helping advance people. how they make decisions and so forth. So giving them more guidance, giving them more instruction. I too don't think that AI just automatically runs a factory for us, but it will over time start to incorporate more rules and alerts and things that we can spend a little less time trying to figure out ourselves. So I promised to show you a few of these. This is going to go really fast. So Whirlpool, washing machines. I literally promised you a washing machine. And this idea of looking in aggregate, so not just a digital twin, but looking across an entire product line of their connected Whirlpool appliances. You know, what are the average load sizes that they see? We design based on market feedback, but the products actually tell us way more than the customers ever did. In this case, we're also drilling in and looking at the products that are in their test lab. They spend an inordinate amount of time testing every product for extreme durations, and now their engineers get operational insight into, is the product that I'm designing, so this, I'll use the prototype example that Michael had, meeting our expectations and starting to couple it. I'll apologize for the Japanese here, but Hirotech is an automotive supplier. In this case, they are taking over 400 data points. You can see in the photographs here, they're taking photographic inspection of welding and all the data on this from the digital definition. You would equate that to a digital thread. And in this case, they're taking over 7,000 readings on those robots every 30 seconds to understand motor fatigue in the process. And they can equate that all back together to understand the product quality. And it saves them weeks worth of effort in all the diagnostic and triage. Massive, massive savings to them. And for everything they add, it gets better. In this case, this is, I apologize, this is going a little faster than I could control the clicker here, but for model-based systems engineering, so for people that are doing kind of high-end system modeling and code generation and the things that we heard from Terry and the MathWorks team, we're able to now use this to drive complex simulations. So behind this is the kind of the software intelligence, if you will, for an electric car. And behind that is a series of simulation models that are actually from MATLAB and Simulink, which are MathWorks software. And what we're doing is we're driving it through spaces, but in this graph that you see here, we're comparing the actual car that's driving the street and the data that's coming off it to what the simulation is, and starting to drive and bring those data points closer and closer together. So in the prior video, the actual simulated version was off relative to the model. We just didn't have enough insight into it. And that flashed a little bit quick, but this is an evolution of it for an electric car in Germany that we can now do some co-simulations where as the cars are being tested and performed as they bring them to market, they can start to evaluate for each car that's out there how well it's actually performing relative to rerunning the simulation for that car, and we can even do it across fleets. This is a similar example to what you saw from ANSYS earlier. So in that motor that you see in the middle here, what you're seeing here is our ThingWorx technology, and with it, we're going to take data about how that's operating through Rockwell's PLCs. So this is just general data that we can get at, but we're going to put it through ANSYS to get at some of the virtual sensor data. The idea of a virtual sensor is you can't really put a temperature monitor inside of a winding in a motor. It's obviously spinning and it's really hard to do, but in critical applications, it's super important to kind of monitor that. And so in this case, we're driving all the IoT data out of those controllers and out of that system in through ANSYS to get at that data, and then put that physics into motion for the operations of these motors. While ANSYS does have a partnership with SAP, we actually co-sell with them as well on this. I'll give you one more ANSYS example in a minute. So these are fairly similar to what you saw in the prior video. Second. And I think this one's an interesting use of AR. So this isn't all the AR that we do, but we're getting really good now at actually being able to see things differently. So you don't have to go into a cave or try to show somebody on a monitor. What if we literally could walk around this Cirrus Vision Jet and start to understand the physics that are inside of that. You're seeing essentially the CFD flow lines of some data that we actually have from this aircraft, but we now have it where we can drive real-time simulation to effectively drive AR as well. So as you move the aileron controls and so forth, you'll actually see where everything is actually impacting right on the physical object. And lastly, if you were to say, how do I actually help make design better? In this case, we actually captured some data from these Polaris snowmobiles, and what we do is map map that time series data on how this snowmobile was actually operating. You could apply it to a car. You could apply it to any product. And in the CAD tool, this is Creo, this is a CAD tool that we sell in the market, start to map that data back so that engineers can make new engineering decisions based on real-world data that we've captured, either on this product line or a prior generation product line. And what you're seeing here is that we're just showing you a quick kinematic of the reactionary forces. It's interesting, when one customer applied that in a race car, they actually came back and said, we've thought for 20 years how this, actually let me finish this and I'll give you the race car story. This is real-time simulation in context of design. So no longer are we shipping a design over to a simulation person to run the simulation. The designer really runs it in context, and it's GPU-driven design powered by ANSYS here, where as the designer now works, they're putting all the logic in up front. And this is actually a kind of a breakthrough thing for us to bring simulation ever so much closer to the engineer who's doing the design work. But back to the race car portion for a second. What they actually said is, for 20 years, we thought that if we applied this much force on the corner of the car, that we would get constant wheel contact through the corner. And what they were able to get by analyzing it that way is they actually saw that the wheel was coming off the ground through the corner. They were actually losing cornering force. And it was shocking to them. Absolutely shocking. It was completely counterintuitive. And part of it is because the physics model that they had didn't have some of the reactionary forces of some of those cornering conditions actually in there. Because we do a lot of things in generalization and assumption, they now had data to kind of prove that that wasn't the case, and was game-changing for them. And similar to that strut on that snowmobile, now we're able to kind of go in and take real-world data that we can measure the kinematics through actually, and then do designs that are around that. Because a lot of the engineering world is based on things like factors of safety. As long as the engineer can hit a factor of safety of 3 or greater, like, we don't have to spend a lot of complex time and a lot of high-end analytics. But where the factor of safety is really tight, I want to free up the analytics people and the simulation people to focus on those jobs and not just the general rigmarole of simulation. And so we're doing a lot of work across that whole gamut to bring it together. So hopefully it was a nice way for you guys to visualize what all the technology looks like as it comes together. With that,
wow.
Any questions?
Yeah. I know we got some questions that are coming in on the Twitter feed, but before we jump to them, Michael, maybe one thing you can kind of help us clear up a little bit. You talked a little bit about it. We've heard a lot of other references to it today, but what really is this thing that we call Industry 4.0, and how does it connect to the digital twin?
Yeah. So again, it's really about basically having a digital twin of your factory. So that's really what 4.0 is really about, is having a factory that has smart machines that can basically sense and communicate back what they're doing into the digital twin, so you have a view of it. I've got, in fact, there's a couple papers out there that I've done that have gotten a lot of uptake. One is the idea that says, if we really do that, we can basically repurpose our factory simulations. Too often what we've done historically, is we do a factory simulation, we basically get it to where we want it, we put it in the drawer, and we never see it again, okay, once we build a factory. We can take that factory simulation now and basically drive it with MES data so that we can basically see what's happening in the factory, in simulation. So that means you don't have to be on the factory floor anymore. And in fact, that's why they, usually in the factories you see the foreman's shop over the factory so he can watch out. Basically means anybody anywhere in the world who's authorized can do it. I call it factory replication. But then the big opportunity is what I call front-running simulation. So the ability of being able to continue to run your factory off of MES data, and every tick of the clock, you basically simulate forward what's going to happen. So from the perspective of the company or the organization, is what you didn't think was going to happen with a clash of robots or a bottleneck, you now get to see. Because what happens in a factory is you're always panicking when you basically have that problem. What I'd like to do is so think of a crystal ball for factory managers. Okay, you'll basically be able to see what's going to happen. And I've got a new webinar coming out that's basically going to talk about the fact that if we're ever going to go to mass customization, we're going to need to simulate ahead of time so that we don't basically throw the stuff onto the line and say, yeah, we're going to do, quantities of one. If we can't simulate that ahead of time to do that, okay, we have no chance of, once we get it onto a physical factory floor, of happening. So I think that Industry 4.0, this basically smart machine, IIoT stuff, really fits in nicely with the digital twin.
That's pretty cool. And Steve, I think that kind of ties in. He was talking there about the mass customization, and I was kind of taken back by your comments. Was it John Deere that didn't have two tractors that were alike coming off the line, or one of your customers?
Yeah, actually several in that column, like John Deere. Yeah, they.
Wow.
Anything that kind of looks like that, because you're now dealing with all the different global emissions variations, the different power factors, the different even attachments. You get to some pretty incredible permutational complexity for them. But you would all see it too if anybody's actually went and ordered a car and see how the options all change. I mean, it's a really nice way to experience it. And I think even though it might look like a few changes to you on the outside, I mean, I think the F-150 truck at one point, the number of options that they gave you for just the base model was generated 6,500 different top-level configurations. And if you think about how that cascades through the bill of material, it's thousands of components and things like that are affected.
Wow.
So just basically a report that came out, I think it was somebody's dissertation. I don't know how many grains of sand there are on the earth, but they came up with 10 to the 27th variations on a luxury car, okay? By the way, for those of you that want to know what that's called, it's a brontobyte, okay? And so you have petabytes and exobytes. Brontobyte is 10 to the 27th. So now you've got a new term, and it's named for the brontosaurus, by the way.
Actually, I have grains of sand right here. It's 7.5 times 10 to the 8th is sand, and 1 times 10 to the 24th is molecules in water. So.
Yeah. Well, 10 to the 27th is the number of variants that you can have in a luxury vehicle. So,
see the bonus, you get a physics lesson if you hang around here till the
it wouldn't be a simulation conference unless we put mole in there too. So 602, 10 to the 23rd. So there you go.
Oh wow, that's pretty cool. So Steve, as you're out evangelizing this product, these tools, the concepts, what are some of the barriers that you see that organizations are facing with actually embracing these new trends and the new technologies?
Yeah, I think if you look at a service organization, for example, one of the issues is IoT is one of these horizontal technologies. So somebody who runs a service organization is almost assuredly they can't single-handedly do it, unlike buying another packaged piece of software. So you could buy a CRM system and run your service organization off it. But with IoT technology, they need to kind of encourage the engineering department to get involved. They need to get IT alignment to successfully drive it. And if they're really forward-thinking, hopefully they're thinking about what the implications are of security in the overall design. And when you start to factor those in on a service organization, those are some pretty compounding organizational factors. And depending on how the organizational hierarchy is set up, that may actually create some gating issues from having it be a small implementation. But it turns out where there's a lot of, I saw the term, I think you used it earlier, shadow IT in one of the slides as well. The opportunity is so big, though, that a lot of customers are out there. And one customer we have, their IT department was so late to the game in figuring out what it was that they had identified well over 50 IoT projects on many different platforms that were already in their organization before they ever got their finger on it. And so many businesses where there's a will, there's a way. And inside manufacturing, I think they're wising up as well. Organizationally, historically, plant managers have had a lot of P&L control over what happens in their plant. But there hasn't been a lot of what I would say knowledge sharing because it was a competitive situation inside most of the companies where the plants are competing. That's changing. Centralized manufacturing IT organizations are getting created and horizontal visibility. So the idea of having a factory foreman, look over the factory floor doesn't fly anymore. The COO wants to be able to see at a glance, like what's happening across my organization. And as a result, that's really driving a lot of the change here. But the scale, it's a big scale issue. Like what pain points and what problems are the largest business use cases to kind of go after. and how do you do it in a very agile way. The HeroTech case maybe being the best agile case I've seen so far, where they absolutely constrain their work and they don't spend endless cycles on it or treat it like a typical software IT development project. Because to put it into perspective, if you took a 6-month IT project on an organization that had several hundred factories, it would take 20 years to run that digital strategy if you ran them serially. So you definitely need to do it a different way.
Wow, that's pretty amazing. It's pretty complex, but it's also pretty exciting to think about being able to look at one screen and see what's going to be happening in my factory in 5 or 10 minutes, and then looking at the one at what's happening in real time, and seeing the correlation of those, and being able to hopefully take some preventative action in that 5-minute window that you have into the future to prevent that disaster that you saw on the one screen. So. Exciting times and lots of things that are changing. So you got a question online there from somebody's Twitter account? Can I read that? What is the likelihood of partnering with Germany or other countries on applications of the IIoT in order to integrate digital twin research innovation?
So that's an interesting question. I mean, I guess from the perspective of, do we know what industry, i.e., INDUSTR, i.e. 4.0 is? Germany has specified a great deal of that. So there's really no kind of secret that they're holding. So I think that there is ability, and information, wants to be free. And so we're basically getting that kind of out. I think there is sort of kind of two levels of it. I think that there is sort of non-competitive stuff that we can do research on jointly, and I think some of that's happening, and you see that happening in conferences all the time. I think that there are areas where it's going to be defined nationally. So we've created these, the United States has created these whole things called NNMIs, the National Network of Manufacturing Institutes. I'm sort of mixed on how well they're doing, but they were supposed to be sort of the U.S. version of the Fraunhofer and the Germany version in terms of being able to pick areas of research and then apply them, okay? The problem we had is that we have funded basic research, and then we have commercialization. And in the past, when companies could afford it, they basically did the whole line of innovation, not only on products, but of manufacturing. Well, there's this thing called the Valley of Death, which for those people who understand technical readiness levels, from about 4 to 7. So you get the thing developed, but in order to be able to get it to commercialization is really, really tough. And we have sort of lost that, and that's what the NNMIs have intended to do. Don't think they've done it very well, is my personal opinion. Overall, I think some areas like America Makes has done a pretty good job in terms of the additive manufacturing, and I'm with you. I think it's a huge disruptive technology. Sort of my version of sort of how the digital twin works is I would like to design the product virtually, test the product virtually, manufacture the product virtually, support the product virtually, and only when I get it all right do I want to go out and make it. And by the way, what I really like to do is just print it. And so I think if we can get to that point where the digital twin is you do all the work over here, because oops in the virtual world doesn't really mean the same as oops over in the physical world. And so I think that if we can get that to go, I think that's a huge opportunity for the United States. So I think there's sort of two levels here. One is sort of non-competitive, we'll share knowledge, but I think that countries do tend to organize around specific technologies that's probably not going to be shared across national borders.
Yeah. Maybe to reply on that, so we do partner with the University Architect and their E4TC, so they have a big industry 4.0 capability there. We're also partnering with companies that are kind of working through that. The interesting part about Germany is, for as big as it is as a world economy, you can drive across it pretty easy. Yeah. And so for that reason, they have a lot of really condensed synergy that's just very difficult for us to cover here coast to coast. That's working in their advantage, and we're kind of taking advantage of that, working with all of the wonderful customers we have in Central Europe there in Germany, and then extended beyond that. So we've definitely turned that as a place for us to collaborate inside of Europe, if you will, and also bringing customers in. So it's completely open to let customers in and see it. The likes of McKinsey and Deloitte and others are also leveraging the facilities that way. That's the best place I've seen it. In the United States, there's nothing that coalesces us quite like that here. It's a lot of very point-specific areas where we're working in various different industry channels and so forth that kind of create a similar type of working experience, if you will. For whoever submitted the question, feel free to contact me on Twitter, and I'll connect you.
How about a live question? Anybody in the audience got one? I know we got another one in the queue here from Twitter, but I see a hand way back there.
Hey there, Mike. I really like your idea of the virtual factory and being able to do all of the different stages from anticipation through digital twin and implementation virtually, and only print it at the end. And Steve, I like how you've been able to partner with a lot of companies in doing digital twins and getting there. So if we can do all of this virtually, and we can then print it at the end, and we can see that real factory physically operating anywhere in the world, why do we need manufacturing in the United States if we can do all of the steps virtually here and then see the manufacturing and logistics take place worldwide across all of the different markets separately?
So let me answer that, and that is that the whole idea of design here and produce elsewhere generally becomes design elsewhere, produce elsewhere. And so the issue of being able to manufacture it ourselves, I think, is critical in terms of being able to maintain the innovation. You really can't basically just say, we're going to innovate here on the product, and the manufacturing innovation doesn't mean anything. And by the way, the idea that says I'm going to actually print everything is not. If I was indicating that, I apologize, because there will always be subtractive manufacturing and there will always be assembly operations. Okay, the three key things in terms of additive is, can I take weight out of the product? So instead of a solid strut, a lattice strut, okay, with the same structural characteristics, can I reduce part count? So taking 40 parts down to a couple. The poster child for that is GE's LEAP engine, fuel nozzle, and their new engine that takes parts down by a magnitude. And then the third thing is adding capability to a part that you couldn't. So putting cooling tubes in turbine blades. Mm-hmm. So the thing is that those are inextricably kind of combined, not only with the design piece, but with the manufacturing piece. So we have said, yes, the model is we don't really care if we manufacture it, we just want to design it. The people that are manufacturing it are pushing back onto the design side. So if we are not manufacturing it in a few short period of time, I don't know if it's a decade or a couple decades, we won't be designing the stuff. So I absolutely believe that we have to manufacture it. And that's not even saying the national security interest of, if we're not manufacturing our own stuff, who knows what we're getting, from other countries in terms of things that first of all, can we get it? And second of all, can we get what we think we're getting? So I'm a big believer that says, first of all, the additive manufacturing thing is a piece of manufacturing, but we basically need to manufacture here if we think we're going to design here.
All right. Thank you all for the great questions, and thanks to panelists here. I see Tom's coming back up to the stage. I think that's our hook that says it's probably 5 o'clock somewhere or something like that, that we ought to get off the stage and let him wrap this thing up.
It's 5 o'clock in Brussels.
Thank you very much, Steve.
Thank you.
Thanks, Mike, as always, man. Thank you very much.
Good seeing you. Thanks.
All right, so as my co-chair Bev mentioned this morning, kind of what our primary objective in the 4 years that we've hosted this summit is to broaden our collective awareness of the commercial uses of simulation beyond aerospace and defense. Our keynote speakers, and I think the panelists did a great job today, but I still think, even over 4 years of working at this, we've just scratched the surface in our understanding of the many applications of modeling and simulation in today's and tomorrow's world. So, I think our intent is to bring this back next year. Sadly, Mayor Jacobs will leave office and move on to be the Orange County School Board Chair. Our current sheriff, Jerry Demings, will take her place, and my intent is to try to get to him early on in his administration and try to convince him that this is value added, this conference, and that we need to do the 5th one next year in the September timeframe. So we'll work on that. But let me leave you with just a couple of thoughts about simulation in Florida. It is big business. It contributes about $6 billion to Florida's gross state product each year. The engine that drives the simulation industry is a 40-acre Navy base that is the centerpiece and the anchor tenant of the Central Florida Research Park, right just south of UCF. Co-located there are all 4 of the military branches and 9 other government organizations that are all involved in advanced R&D and the acquisition of training devices, simulators, and other simulation technologies to meet the training requirements of America's warfighters. Through the efforts of the Metro Orlando Defense Task Force, which includes the Orlando Economic Partnership, the High Tech Corridor, the Orange County Mayor, the Orlando Mayor, the National Center for Simulation, the University of Central Florida, the Central Florida Research Park, and Mayor Jacobs' Modeling and Simulation Blue Ribbon Commission, this community convinced the state legislature to invest an additional $42 million to expand the partnership complex in the research park and set the conditions to grow the simulation industry in Florida. 207,000 additional square feet of office space have been acquired to do a couple things. One, reduce space overcrowding. We had a lot of our federal workforce living in high-cost commercial space. And in so doing, we lower their cost of occupancy of that non-Navy federal workforce that works and drives this industry. But more importantly, the 2 partnership buildings will bring new mission and capabilities to Orlando, to our simulation cluster. Partnership 4 has an expansive high bay space that will be transformed into an advanced research and development rapid prototyping facility to support emerging programs across all of the Team Orlando commands. The Army is also committed to move the synthetic training environment cross-functional team headquarters here to Orlando to be co-located with the Army's Program Executive Officer for Simulation, Training, and Instrumentation. And on the 4th floor of the Partnership 5 building, the newest of the acquisitions, it'll be transformed into a secure compartmented information facility to support exploding requirements in cybersecurity training. None of these initiatives, none of the things that I just mentioned, would have been possible without the strategic investment by the state of Florida and the commitment to expanding the simulation cluster here in our Central Florida Research Park and the Central Florida area. So this is big business. Big business that employs a lot of people and brings goodness to the state of Florida. I'd like to once again thank all of our sponsors. If we can get the slide up one more time to show them a little love. I'd also like to thank our planning committee, my co-chair, Bev C. I'd like to thank specifically a couple of folks from Orange County. Eric Ushkowitz, Business Development at Orange County, and Casey Brinkley, who Eric has been kind of responsible for shepherding the efforts of Orange County, but Casey Brinkley has done everything that has to do with IT and logistics to run this conference over 4 years. So we owe them a big round of applause. So I'm going to assume we're going to be successful, and we're going to do this again next September. So I'm inviting all of you to come back. We'll have another exciting program we'll try to put together here in the next several months to get going again. Our thanks go back out to Mayor Jacobs once again in Orange County for their continued support of our industry. And Bev, yes? Yes, if you've got great ideas, if things that you would like to see, topics that we could cover, experts that we could invite to come and speak to us, send us a little note. You can send it to tbaptiste@simulationinformation.com. And we'll put that into the plan and see what we can do. But with that, we are adjourned. Have a great day and drive safe.